So, I'm Sarah, and as I've been introduced, I am currently a tech lead at Gousto. I'm actually quite a new hire, having started last week. Previously though, I've been a tech lead at another startup and senior engineer at multiple other startups. Before that, where I've helped numerous companies solve the problem of how to scale up a monolith using modern infrastructure practices. The one infrastructure practice I like to use is event-driven architecture. So I hope from my talk today, you're all going to go to work tomorrow and tell your CTOs, head of engineering, directors that event-driven architecture is what you should be doing, and everything you're doing right now is wrong. So, what is event-driven architecture? There's a lot of ideas about what it is, what it isn't. I'm here to try and tell you what I think it is. So, event-driven architecture is a software design pattern in which decoupled applications can asynchronously publish and subscribe to events via an event program. This probably sounds a lot like messaging-based architecture, but there are some subtle differences. But first, let's go over exactly what I mean by what I just said. So, decoupled applications. If you're building event-driven architecture, you're most likely following domain-driven design. You have different services or microservices that are split up over multiple domains based on your company or product. They asynchronously publish and subscribe, so you'll have an event bus or an event broker or a data stream that your services communicate via. You can also, in event-driven architecture, communicate synchronously as well, but your primary method of communication between services would be asynchronous. So, scaling for usage. Obviously, one of the biggest problems most companies face is how to scale up for usage. If you're working with a monolith, you've probably hit a load of bottlenecks, probably with your databases, or your network calls, or any other problem. Using event-driven architecture, you will inevitably have more decoupled services. So you'll probably be following domain-driven design, and you'll have a lot of separate services, microservices that can be scaled independently. And the scaling of those are more effective. So your usage is spread across all your different services, so their load is automatically brought down compared to what you would be using for a monolith. You also will be using an asynchronous communication layer for all your services to talk to one another, which also reduces the impact of those services communicating. Whereas if you had a synchronous communication layer, something like a REST API or a SOAP API, then those services would be communicating synchronously and creating a network latency where they're waiting on each other to respond or waiting for their databases to fetch data for you. When you're using an asynchronous layer, you do not have that network latency, but you do have to be mindful that you won't always get data immediately when you request it, but it will come eventually. So event-driven architecture also allows you to scale your engineering teams. So previous speakers, Georgina and that, probably summed it up better than I'm going to, but with event-driven architecture, you're going to be using domain-driven design, and with that your domains are much more clearer, your teams know exactly what they own, they have less to worry about, the ownership of services is much more easily defined, and also with event-driven architecture you have a very defined communication pattern that your services share, which means building out new services is easy, you already know which event you're going to consume, and such you don't have as many blockers waiting for other teams to set up a REST API to find the data you need. The events are already there. So, what is an event? So, an event is not a message. This is a common confusion I find that a lot of software engineers have, is the difference between an event and a message. In a messaging layer, you are probably sending a message from one service to one other service, and that message is probably telling the service what to do. In event-driven architecture, you are sending an event just to your bus. You don't care about who's receiving it, that's not for your service to worry about. So your event should not describe what happens with the data inside of it. So to give you an example, not an event. So we see here that someone may have signed up to a website for the first time. A message will say it will have a type, so this might be your message type, which is just saying send a welcome email, and it's going to tell the service who to send it to. So that is prescribing logic to the consumer of that event. And that's not what we want to do in event-driven architecture. As an event, we will still have a type, but this will be more generic. So this is describing what has happened, the user has signed up, and the state relating to that action. So we're just going to say a user has signed up, they have signed up with the email and example.com. So just to reiterate, the first one prescribes logic, so you have coupled your services together by prescribing the logic. The second one does not prescribe what should happen when someone consumes this. As such, your services are not coupled logically. So, I want to go over a few approaches to event-driven architecture. In event notification, it is very similar to message-based architecture. A producer will create an event containing only the information that the event has happened and metadata for the entities that event has affected. So in my examples of these, we're going to see a user creating an order, say for an e-commerce website. So in event notification, the user could create an order, they could update an order by changing their address perhaps, and they could cancel an order, creating an order deleted. In event notification, you are simply stating that an event has happened and the entity on which that event has happened. So all of these events look identical, and only the event type is different. So, to have a look at what architecture that may look like, so in this example we have our order service, and we have our fulfillment service, which is going to send out the order and handle the delivery. So our user here places an order via the orders API, that gets saved to a database, and they get a 200 response saying order is successful. And then in the background, orders API fires off an order created event, which goes to your event bus, and the fulfillment service will consume that event and see an order has been created. I must now find out the data about that order. So it makes a synchronous request back, most likely via a REST API to say, I would like the state of this order, please. And then it can handle processing the order. So this is what I meant by, in some event-driven architectures, you will have synchronous requests. As to retrieve the state here, it has to make a synchronous request back. So, the next type of approach you can take is event carried state transfer. And this is my personal favourite kind of approach to event-driven architecture, but not for everyone. So, in event carried state transfer is the equivalent of REST, I've been told a lot. And in this, a producer creates an event that contains the full state of the entity affected by action. Deletion events are handled slightly differently with event carried state transfer using a process known as tombstoning. So in tombstoning, you would send an event that only contains the ID of the entity, all the rest of the state is removed. This to signify that the state relating to that ID has been removed. So, if you were using Kafka, for example, this is very good for this sort of approach to event-driven architecture, as it has what's called a log retention policy. So you can always keep only the most up-to-date version of an entity inside of your data stream. So, what might the architecture of this look like? So this is a bit more simple compared to the previous example. We have our user, he creates an order in the orders API, that gets saved, he gets a 200 back. In the background, we just produce an order event, and that has the complete state of an order, and the fulfillment service can retrieve that full state. And it doesn't need to make any requests back, it can start handling and filling the order. Finally, we have event sourcing. So this is probably the least common approach that I've seen companies use. And in event sourcing, a producer sends an event containing only the state that has changed on an affected entity. The benefit of this is you can always rebuild any database from your stream. If you replay the stream from the beginning, consuming everything in time order, you can rebuild your database perfectly. So, what might events look like? As I said, order created will have the full state. Order updated would have only what's changed. Order deleted would just contain the ID of the entity that's been deleted. And the architecture of that would look a bit more like this. So in event sourcing, you're going to have a much more asynchronous process for your user. So our user places an order, but they don't get, well, they get a 200 back to say accepted, but the order hasn't gone through yet. It's processing. So the user places an order, and we create an order created event. Now in event sourcing, the service that produces the event also consumes it. So we see here, the order service also consumes the order created event to save it to its own data store. Once it's saved it to its data store, only then does it notify the user that the order has been successfully created. At the same time, the fulfillment service is also consuming the order created event, so it can start fulfilling the order. So, that is the end.